Question number 23. A tank with vertical walls is mounted. A tank with vertical walls is mounted so that its base is a height h above the horizontal ground. The tank is filled with water to a depth h. A hole is punctured in the side wall of the tank at a depth x below the water surface. To have the maximum range of the emerging stream, the value of x is to have the maximum. It should be to have maximum, the value of x is h plus h by 4, h plus h by 2, h plus h by 3, 3, h plus h by 4. So this is the problem on hydrodynamics. Now we will take the problem like this. So a base has been made of a height is a capital H. On this a tank has been mounted and it is filled with water. A hole is made at a depth of x. Then water comes out. Now what is the condition for the maximum range? Now water is filled to a depth. This full depth is given as small h. Now the time taken by the stream to reach the ground, we can calculate V's using the formula S is equal to ut plus half gt square formula can be used. So here S is h, initial velocity is 0, so it is going to be half gt square. So time taken equal to 2y by g is the time taken. So what is the range of the water stream? Is a range is a velocity of the water comes out into time taken for the water to reach. So this is going to be, it is the height is it is 2gx. So velocity is 2gx into t. T is a root of 2y by g. So this is going to be root of 4xy. This is a 4xy is going to be the answer. Now we will go and calculate the remaining things. So range R is equal to 4 into x into, what is y? Y is the depth, it is converted as h plus h minus x, because y is the distance from here to here. So this is h and this is h, total h plus h minus x will give this depth here. So this is h minus h plus h minus x. So this is the range. So the formula for range is 4x into h plus x minus x. So to have maximum range, we can even take it as a 2 into x into h plus h minus x also we can say. Now to have a maximum range, differentiate this equation and then equation differentiate with respect to time and equate to 0. So for maximum range, dr by dx should be equal to 0. So if you differentiate this above equation, so we have like this, dr by dx on differentiation we will have h plus h minus 2x divided by h plus h minus x whole power half into x power half is going to be 0. So since numerator cannot be 0, since denominator cannot be 0, we can say, because if denominator is 0, it's going to be infinity. So this denominator cannot be 0. So we can say, to satisfy this equation, h plus h minus 2x should be equal to 0. So x is equal to h plus h by 2. So answer is B, h plus h by 2 is the correct answer.